In this video, we're going to introduce a number of functions, and particularly we're going to look at the graphs of these functions that we're going to have to use over and over. And so we're going to refer to these as our toolkit functions, in that we're going to have to use them a lot in this course and in future courses. So we want to know them really well so that we can kind of pull them out of our toolkit whenever we need them. So the first one we're going to take a look at is the constant function. So it's expressed in this one as the example f of x equals 3. Now, one of the things that I want to remind us of here is that, this f of x, this function notation, right, is really just telling us what the output of the function is. In this case, it's the y value, right? So when you say f of x equals 3, we can, of course, just say y is equal to 3. And anytime we're looking at a function, it's justifiable to make that substitution in your mind. So when I say y equals 3, what does that really mean? It really means that, yeah, y equals 3, but y equals 3 no matter what x is. Right? Y is 3 no matter what x is. So the fact that x doesn't appear anywhere on this side of the equation means that it doesn't matter what it is, and so we just let y be 3 for all these different x values. All right, and then of course we have what's called the identity function, which is f of x equals x or y equals x, right? So that just means whatever x is, y has to be, and so that's why no matter where you go, if I go over, over here 5 on the x, then I'm going to have to go up 5 on the y to get to the spot, the proper spot on the graph. Oops, I meant to say 5 there. All right, so that's our identity function. Now we'll start to look at a couple more interesting ones. So our quadratic function. So f of x is equal to x squared. So let me just be really specific about what you should be able to do in terms of recalling the important facts about the y equals x squared graph. So we know that if we take x equals 0 and square it, then that of course gives 0, right? So y would be 0. If x is equal to 1, 1 squared is 1. And so what I'm really doing here is just making a little table. So 0 squared is 0, 1 squared is 1. And then we want to know what's happening when x is equal to 2. All right, that puts us up to 4. Why? Because 2 squared is equal to 4. And then 3 squared is, of course, 9. All right, so I want you to be able to spit those 4 ordered pairs out immediately when I say, sketch for me y equals x squared. And then, of course, we know that when you square negatives, it turns positive again. So you get the exact same y values over here on the negative side. All right. So just to kind of give you a sense of where we're going to eventually go with all of this is later, what I'm going to ask us to do is to graph things like this. F of x is equal to 2 times x minus 3 squared. Let's do minus 4. Okay. So you're going to look at this and recognize, hey, I've got a square here where my x is. So that must mean this looks something like the more simple quadratic function f of x equals x squared. All right, and you'll learn this later, so you don't know this yet necessarily, but I would know by looking at that equation that the vertex, the bottom of this function, should be right here. Okay, and then I also am going to know that if normally I go over 1 up 1, in this case, because of what I'm seeing in the formula, I'm going to go over 1 up 2. If normally I go over 2 up 4, in this case, I'm going to go over to up 8. All right, so I'm using my knowledge of this graph to be able to graph this more complicated one. And then I also know the same things happening on the other side. Okay, now again, you don't necessarily know how I knew those things at this point, but this is what we're eventually going to do. So you can see how important it is to be able to have the original y equals x squared function really tattooed in your mind so that it makes it easier to come up with this more complicated function here. All right, so we'll take a look at another one now, the square root function. Okay, so the square root function is where we take whatever x value we have and we take its square root. Now, one thing you do need to understand is that the square root symbol always means the positive square root. So, so just as an example to kind of sort this out here, I can say that -3 and 3 are square roots of 9. Okay, that's absolutely true. However, if I ever put this on paper, 9 with this particular symbol, this means only the positive square root. Okay, so that's why this graph looks the way it does, is because you're only seeing positive y values come out here because we're using this positive square root symbol. And by the way, if we did start throwing negatives in there as well, then it's no longer a function, right? Because you would have one input going to 2 different outputs, right? So, so that's what we're talking about. Now, when you make the table for this, you actually kind of want to do it backwards of the way we did it for y equals x squared. With y equals x squared, we started with the x and saw what y popped out. Here, because of the nature of the square root and the fact that the square roots of lots of numbers aren't pretty, what we actually want to do is start with y values and then square those y values to get the x that it came from. So, all right, if I have y equals 0 here, then squaring 0 gives me 0. If I start with y equals 1, squaring 1 gives me 1. Now, if I put a 2 here, then squaring 2 gives me 4. So what's the thinking here? Well, the idea is that the square root of 2 and the square root of 3 don't give pretty answers. They give numbers between 1 and 2. So the reason I'm starting with the y is I guarantee that my y value is going to be a nice number, and then the x value is also going to be a nice number because the square root of 4 is 2. Put a 3 here. The square root of 9 is 3. And so anytime I ask you to think about the square root graph, basically these are the 4 points that you just kind of immediately jump to mind. And you'll notice that the graph starts at x equals 0 because we can never plug negatives into a square root. And we'll talk about that in more depth later. But just think of it like this. If I said the square root of -9, that would have to mean that something times itself, right? Something times something equals -9. But you know that if you multiply something by itself, it's always going to be positive. So we know that negatives don't work there. So that's why we're starting at x equals 0. All right, kind of along similar lines to y equals x squared, we also have y equals x cubed. Right, so when we want to think about these kind of special values, we can start with 0. 0 to the 3rd power is 0. 1 to the 3rd power is 1. 2 to the 3rd power, well, that's 2 times 2 times 2. That's going to be 8, right? So that gives us this point, and then when I go over 2, I go up 8. All right, now what makes this one different than y equals x squared is that we don't have the same thing happening on the negative part of the graph. Because if you take -1 to the 3rd power, that's -1 times -1 times -1. But 3 negatives multiplied together gives you a negative. So go left 1, we're going to go down 1. And same thing with -2. -2 to the third power is 3 negatives multiplied together, so that's going to give me -8. All right? So we want to have this picture in our mind anytime we're thinking about y equals x cubed, because we'll do more complicated graphs like I showed you with y equals x squared. So we want to have this committed to memory so that it's in our toolkit of functions and ready to go. And then we can also talk about the cube root. All right. So again, let's start with y values instead of x values as we did for the square root. All right. So, how can I produce -2, -1, 0, 1, and 2? Well, if I cube this, okay, then if I take the cube root of -8, I'll get -2, right? And so we're just, again, kind of working backwards here so that we can come up with this graph of the cube root function. All right, and then on this, these last couple graphs here are the reciprocal function, and then we'll look at the reciprocal squared function. So the reciprocal function is when you're saying that f of x or y equals 1 over x. Okay, so you can kind of think of this as like the flipping function. It takes whatever x value you have and it flips it. All right, so let's go ahead and take some care to go ahead and plot some of, or sorry, come up with some of these in the table and then plot those points. So if I put an x equals 1 in there, that's pretty straightforward. 1 over 1 would be 1. So that means when x equals 1, y equals 1. Okay, I can see that. All right, what about when x is equal to 2? Well, then I'd have 1 over 2, which is just a half. So that's why when I go over 2, I go up only a half. All right, now let's look at what's going on in here, though. Okay, if I go to x equals 1/2, so I'm starting off with x equals a half. Let's see what happens. Well, this equation tells me to take 1 divided by the x value. So that's 1 divided by, I can just change the symbol to 1/2, or divided by 1/2, is equal to 1 times 2 over 1. So when x equals a half, y is equal to 2. So that gives me this point. Now, generally what's going to happen, though, is the closer that this bottom number gets to 0, let's just take a half here, for instance. The closer that that gets to 0, the bigger the entire number becomes. And let's just, kind of do a ridiculous example here. What if I said 1 over 1,000 as my x value? Well, then the function would be 1 over 1,000, which we saw how that worked with 1/2. It's 1 divided by 1/1000th, which is equal to 1 times 1,000 over 1. So when the x is 1/1000th, that means really, really close to x equals 0. We are all the way up at y equals 1,000, and of course we can't graph that. So the smaller the bottom number gets, the bigger the y value gets. Then the exact opposite thing happens here. The bigger number that I put in for x, the smaller the y value gets, right? Because if I put like 1,000,000 in here for x, it would be 1 over 1,000,000, which is very close to 0. So what's happening on this part of the graph is that as you get closer and closer to x equals 0, the y values grow just out of control. They go up to infinity. And when x gets big, the y values shrink towards 0. And then we have, the same sort of analysis works over here. It's just that when you start plugging negative values in for x, of course, the y value is going to be negative. But note that you can never put 0 in for x, right? So we know that it's not okay to divide by 0. So there is no point on the graph when x is equal to 0. Okay? And we'll, again, look at this function in more detail later, but I want you to have these basics down right now of just generally what it kind of looks like. Oops. All right, so last function here is the reciprocal squared function. And really similar analysis to what we just did, so if I put in x equals 1, then 1 over 1 squared is still 1. All right, so that gives me that one. But if I put in negative 1, we know that squaring a negative turns it positive, right? So when you go to negative 1, you're also up at positive 1. But then we still have the same dynamic happening that we had before, right? The closer your x value gets to 0, the bigger the y value has to become, and the bigger the x value becomes, the smaller the y value has to become. So it has that same sort of action that the 1 over x function had. It's just that both sides are going to be positive. So just to kind of wrap this up, these are the basic toolkit functions that I want you to be able to call upon without too much trouble. Okay, so what your task really is at this point for this little section of your notes is just to study it, and maybe even on a blank sheet of paper, make a little graph and just say, okay, can I sketch these at least 4 or 5 points that are on each graph, without having to take too much time to do it. That's the point we want to get to, is that we start coming up with the ordered pairs for these graphs pretty fast.